Okay, hi everyone, Assalamualaikum. So this is the last subtopic in the electrochemistry lecture, which is the electrolyte cell. Okay, an electrolytic cell is a type of electrochemical cells where an electrical current drives a non-spontaneous redox reaction. This process is called electrolysis. At the anode, which is in the terminal positive, oxidation process takes place. At the cathode, the negative terminal, reduction process occurs. Electrons are pulled away from anode and pushed toward the cathode by the external power supply. An electrolytic cell consists of two electrodes immersed in either a molten salt or an ionic solution. These electrodes are connected to an electrical power supply, which is usually a battery. Normally, inert electrodes are used, electrodes that do not take part in the reaction. The battery acts like an electron pump, supplying electron to the cathode and removing them from anode. Remember, the rule red cat reduction happens at the cathode is similar with the galvanic cell. Electrolysis always lead to the chemical changes such as decomposition of an ionic compound, release of gases, decomposition of metals, or even erosion of electrodes. Once again, let's look into the differences between galvanic cell and the electrolytic cell. In the galvanic or voltaic cells, a spontaneous chemical reaction produces electrical energy. An anode, negative terminal, and the cathode is positive terminal. In contrast, in electrolytic cell, electrical energy is used to drive a non-spontaneous chemical reaction. Here, anode is positive terminal and the cathode is negative terminal. So remember, galvanic cells produce the electricity while electrolytic cells consume the electricity. How to predict the products of electrolysis? In the electrolysis of pure molten salts, the anion is oxidized in anode and the cation is reduced at the cathode. For example, in molten sodium chloride, at anode, chloride ion are oxidized to chlorine gas. Meanwhile, at cathode, sodium ion are reduced to sodium metal. The overall reaction gives sodium solid and chlorine gas. Notice that chloride ions cannot be reduced further and sodium ions cannot be oxidized further, so they undergo the opposite process. Let's say we have the mixture of cations or anions. How to predict the products of the electrolysis? When more than one type of cation or anion is present, only one cation and one anion will be preferentially discharged. The cation that has more positive electrode potential is reduced first. For example, between sodium and potassium ions, sodium is reduced more easily because its potential is less negative. On the anion sides, the ion with more negative electrode potential is more easily oxidized. For example, between chloride ions and iodide ions are oxidized before chloride ions because the electrode potential of iodide give more negative value compared than chloride ion. So, we always compare electrode potentials to predict which product will form during electrolysis. Now we move to the electrolytic cell and Faraday's law. Faraday's first law states that the mass of a substance produced at an electrode during electrolysis is proportional to the quantity of electricity passed through the electrolyte. The charge Q is equal to current multiplied by time. Q equal to I times T. We also know that 1 mole of electrons carries a charge of 96,500 coulombs, known as 1 Faraday. This allows us to link the electrical current directly to the amount of substance deposited or liberated during electrolysis. Apply Faraday's law in an example. Suppose we want to calculate the mass of aluminium. It produced in 1 hour from the electrolysis of molten aluminum chloride when the current is 10 ampere. Step 1. Calculate the charge. The charge Q equals to current times time. That is 10 amperes multiplied by 3600 seconds, which equal 3.6 times 10 to the power of 4 coulombs. Step 2. Calculate the number mole of electrons. Divide the charge by Faraday's constant, 3.6 times 10 to the power of 4 coulombs. Divide by the 96,500, give 0.373 moles of electron. From there, we can relate it to the stoichiometry of the half cell to determine the number of aluminum, which is 0.124 mole of aluminum. Last step is calculating the mass of aluminum deposited by multiply the number of mole of aluminum with its atomic mass. Then you will get the mass of aluminum deposited is 3.36 gram. Now let's try another practice. How much of calcium will be produced in electrolytic cell of molten calcium chloride if a current of 0.5 ampere is passed through the cell for 1.5 hours? Remember, at the cathodes, calcium ions gain electrons to form calcium metal. Meanwhile, at the anode, chloride ions oxidize to chlorine gas. You can use Faraday's law and stoichiometry ratios to solve for the mass of calcium produced. From the half cell in cathodes, it shows from the stoichiometry ratio that 2 mole of electron is equal to 1 mole of calcium metal. Before you do the calculation, you need to convert the unit of amperes into coulomb per second and time in hour into seconds, which is 1.5 is equal to 5,400 seconds. Then you can calculate the mass of calcium produced in the electrolyte by calculating 0.5 coulomb per second times with 5,400 seconds divided by 96,500 coulomb and 2 moles of electron. You will get the number of mole of calcium produced is 0.01399 mole. Final step, multiply the number of mole of calcium with its atomic mass, which is 40.1 gram per mole. Then you will get the mass of calcium produced is equal to 0.56 gram of calcium. Next, we move to the application of electrolytic cell. One of important industrial application of electrolysis is the production of aluminium. Aluminum oxide is dissolved in molten cryolite to lower its melting point. At cathode, aluminum ions are reduced to the molten aluminum metal, which collects at the bottom. At the carbon anode, oxide ions are oxidized to oxygen gas. Unfortunately, the oxygen reacts with the carbon anode, producing carbon dioxide. As a result, the carbon anodes need to be replaced regularly. The overall reaction produces aluminum metal and oxygen gas. Another application is electroplating process. This is the process of coating a thin layer of one metal onto another using electrolysis. For example, to coating a spoon with silver, we use a silver anode and placing spoon as cathode. Both are placed in a solution of silver cyanide. At cathode, silver ion are reduced and deposited onto the spoon. At anode, silver metal dissolve, replenishing the ions in solution. This way, silver is gradually transferred from anode to the spoon, creating a protective and decorative layer. That's all for the electrochemistry lecture. Thank you very much for your attention.